Welcome everyone to our talk today. This is another talk in the research talk series, and my name is Brad Johnston, and I'm the material librarian in the architecture library. I'll be your moderator for this discussion, and then we have Amy Trendler, our amazing architecture librarian, who's going to assist in monitoring the chat and starting the recording. So this theme is something that Amy and I had talked a lot about and we find incredibly compelling. So it's really this intersection of making and research, and we're gonna sort of explore this topic about how designing and building and fabricating and really working with materials is very much intertwined in research, a type of research and discovery. And so our format is really quite straightforward. We're going to start with some quick introductions that I'm going to do for the panelists, and then we're going to dive into some discussion questions that we've put together. And then at the end, we may have some time for questions from the audience. So please be thinking about those as we go. So to get started, I'm going to go around and introduce our panelists, as I said, briefly. So first, we have Colby Gray, and this is our director of digital fabrication. And then the project that we see in front of us is just one of many that he's done, and this is the McVeigh Boardwalk. Next, we have Rod Underwood from the Department of Architecture. Like Colby, many projects that he could discuss. Rod has really been a fixture in the college and worked on design builds for many years. This project, which we're all probably pretty familiar with, was completed just a couple of years ago and is called The Loop. He is currently engaged in another project that the materials and current progress is housed in the DBL, and hopefully he'll tell us about that one. Next, we have Doug Wilson from Construction Management, and he's going to tell us about something slightly different. The materials course, CM250, Construction Methods and Materials. The students actually build and test several different structural materials with the testing equipment shown here. I've been lucky enough to see the testing in progress, and it's really inspirational. The students are very engaged in the process, and it's competitive, and they learn a lot through this. So we'll learn a little bit more about that from Doug. And then we have Natalie Yates from Landscape Architecture. She may share about this project called Calibrate, which was exhibited during Exhibit Columbus. And so really interesting project that also made an appearance here in the gallery. All right, so with that, I will stop my screen share. So it's clear that we have a lot of experience to draw on. So to kick things off, let's just start with a broad foundational question. What is able to be discovered through the physical act of making that you simply can't learn otherwise? And what is it about that process that draws you to it?
I'll go ahead and jump in. I think there's nothing better than touching things, and students do enjoy building things and being creative with their hands. You can watch videos and read about them, but there's nothing like the experience of actually doing it. And plus, there are lots of variables that pop up when you actually do things that aren't there when you read about them or otherwise. So there's nothing better than that, than touching and building, and we all enjoy that sort of thing.
I think the students learn about materials, and you can read all you want, but until you touch a piece of steel or a piece of wood and find out the difference between them, they're just a name. So I think it's a chance for students to screw up too. And I think that's a good thing, because they learn from that, and they learn what other people have engaged in over the years, and they grow. And incidentally, the project that was shown is not mine. It was my students. They designed it, and I just helped them learn how to build it.
I guess maybe similarly, and I agree with everything that's been said, but I would say that for me, making is a way of kind of figuring out questions as opposed to having a question that you go and look for the answer. You don't always know where you're going when you're making something, and you get to experiment with the what ifs. You get to explore materials. You get to explore alternative methods. You can modify things. You can bend them and break them. And my interest in making has more often been in the process of making itself and not actually in the making of something or of an object or the result of the making. How do you understand what is required to actually make something happen or make something work?
The one thing that I'd kind of add to this already great responses is just how one project feeds onto the next one. You know, like there's just takeaways from a specific project that makes you a better drafts person or a better modeler the next time around. It's like those tolerances, those kind of classes of fit that you might be staring at a piece of paper that you're designing something, or you might be looking at your 3D model for hours on end. But again, it's not until you get like everyone's been saying, you get your hands on the material, you get that feedback, and all of a sudden the next time you go to design, the next time you go to model, everything just kind of clicks on a deeper level. So you never stop, you never arrive. You're always learning more and more through the process. And I think that's one of the reasons why I enjoy it so much as well.
Great. So if we back up a little bit, when you're exploring materials or sort of realms or domains that you've not done anything in or with, what is your approach to sort of research at that stage?
Well, I'll give the simplistic answer for me. I don't. I get it and I try and I discover. And I think working with materials is a lot like being in design studio. If you don't try things that you're not sure will work, you're never going to learn anything. And so I love just give me a material and I'll mess with it and I'll screw up. And what's the loss? Yeah, I just learned something as a result of doing it. So I'm not a classic researcher, that's for sure.
Well, and adding on to that, just because in our pre-planning, this story came up, and another faculty member, can you tell everyone about the backhoe story?
I don't, I quite honestly, I don't remember what that was.
They dropped off the equipment at your
Oh, yeah,
property.
yes. I bought a backhoe and I had never driven a backhoe, never used a backhoe, but I wanted to dig on my pond and I bought a backhoe and they pulled up in the trailer and they asked me if I wanted to drive it off. And I said, no, no, thanks. You can drive it off. And they drove it off, parked it in the drive and said, they asked me if I needed anything. And I said, no, thanks. And waved goodbye. And after they left, I got into the backhoe for the first time in my life and learned how to drive it and how to use it and how to dig holes and move dirt. And that's the story of my life. My father never believed in hiring anybody to do anything. He thought that he could learn how to do it. And maybe it's because that makes me cheap or something, but I'm okay with that. Whenever I need to do something, I buy some tools and try to figure out how to do it. I built my house, and I and two students did everything but drywall simply because I hate drywall, and did plumbing and mechanical and electrical and everything. Put on copper siding and roofing on the whole thing, and never done it before. So don't be afraid. Just try it. You can do it.
Mistakes can be fixed.
That's absolutely correct.
I do use it for research purposes, for projects and things I put together, and for my students to expose them to that. I use a lot of manufacturers' websites, and as there are always new materials coming up, and expose them to those things, and also to kind of demonstrate how you can go in there and learn about. Because as far as building things, putting stuff together, what manufacturers recommend is pretty important, in addition to our construction documents.
See, that was a better academic answer.
Well, and Colby had, I'm not going to lead it, but Colby has a really good, we've talked about this at length.
Well, I mean, one aspect I would say for sure is one thing I enjoy is visiting with people who, also love the material. There's lots of other methods I use, I guess, when it comes to research. Some of what Doug mentioned, but making some friends in the process never hurt anybody. Just like reaching out, having a conversation with someone that you caught wind of that enjoys the material, enjoys the process. I think having a good conversation is always a good place to start. Usually, in that conversation, they say something or there's something that just kind of rings true for me as something to press into and continue to learn on my own. And being able to come back to them, visit with them about it afterwards. That's one aspect of learning that I definitely enjoy, that human component as well. So, I mean, just in general, I'm trying to always just kind of make a map of the domain that I'm working on in some fashion, just trying to eliminate any blind spots I might have going in. It's never 100% achievable, but the more and more I can kind of look at the lay of the land, the more my confidence grows, and the more I can kind of use that to kind of start following the processes and procedures that Doug mentioned. So it's kind of holistic, but I feel like that part of that comes back to just sharing the experiences with other people is something that kind of motivates me and keeps it fun.
Yeah.
Can you talk about visualizing the field and what you use? Like you make a literal map, right?
Yeah, well, yeah. I mean, a lot of times there's, all knowledge domains. People are trying to. I mean, that's what academics do, I guess, is trying to map the different bodies of thought that go into influencing a particular subject matter, and so usually multiple people are taking that approach in different contexts. Finding a good resource like I mean, like textbooks. I'm not going to read the whole thing, but if I look at the chapter outlines and the way it's organized, that starts to reveal something. Always like swinging by the materials library, of course, and visiting with Brad and just kind of seeing how thoughts are organized. Always referencing the Construction Specification Institute's organizational system. I mean, it's just, they're out there. There's these different kind of ways of organizing, just information about the materials itself, about how they're utilized and how they're implemented. And I can never understand the whole of it, but if I have some sort of truncated version or abstraction of that, it's just kind of, again, like I said earlier, it helps me feel like I don't have any major blind spots. I mean, I always have some, but and once that's kind of established, then again, just kind of wading into it makes it a little bit easier for me. And everyone has their own process, and ultimately the things that stick the most are the mistakes I make along the way and kind of overcoming the challenges. But yeah, again, for me, just having that starting point, in addition to the right mindset, just kind of makes it a lot more enjoyable.
Well, and I think that brings up failures or challenges or unexpected outcomes. Does anyone have any good stories about these?
Well, I'll just jump in real quick and say that, failure, I guess, tends to bring to mind something that is bad, but in my mind, failure is kind of the point of making. It results in some new information that you can either avoid it next time or employ it because it did something unexpected that you found out. Yeah, so I think just I don't know that I had necessarily. I mean, there's failures in I think every process of making or any good process of making, I guess, in my mind.
I think failure has a sense of it being permanent. And if something is screwed up and doesn't work and you can fix it, then it's not a failure. It's a learning process. And You know, I just think that you got to try things. You have to experiment. That's how you're going to learn. You just don't be afraid. Just be careful. You know,
Especially if you're driving a backhoe.
absolutely. And you have pets that you love.
I think the students think more when they have a real failure on, say, the concrete beam project or the truss project or something like that, or maybe the beam just crumbles and falls apart. I think that it falls apart, and I think there's a little more thought that goes into that than if it just does really well.
Can you describe that project and how it's sequenced and what the students get out of it?
We start out with introducing how materials react to stress and how they fail. And then we demonstrate through tensile tests on rebar and compression tests on concrete how those materials fail and how the stress strain diagram is developed and modulus of elasticity and things like that. And then in concrete beam project, they design a beam. They come up with how that beam's going to be shaped and how they're going to reinforce it. And then they figure out how to build a form for it. And then we pour concrete and then we test them after a while. So it's a strength to weight ratio. The group with the best strength to weight ratio gets the bonus points on it. And they like that competition part. And sometimes they do pretty well. And we've had a few of them, you put them on there and they just immediately crumble because they either put the rebar in the wrong place or maybe they didn't consolidate properly or things like that. So they get a lot out of that part of it. They can see quite clearly, where things go wrong. So it's good stuff. You learn a lot from that.
Is there anything that the students get from that they just, I mean, because when I witnessed it, they were so intent. It's not like some of these equations, right? I mean, they were focused and it was just a competition and everybody's grinning or grimacing. There's like a lot of emotional commitment to it.
Yeah, they're very involved and they're very, it is very competitive and they love to see the results of their work. So it is a fun thing. And I think a lot of times they're all quite surprised at how much load some of these beams and the wood truss and things like that can actually carry. That part does kind of surprise them. So it's they do get into it. They definitely do get into it. It's a fun project. Both projects are great fun for them, and they enjoy building things and breaking things.
And then Colby, so can you talk about how I saw you go through different materials kind of rather systematically, and you had a collection of experiments. Do you want to talk about that?
Yeah, I mean, I think kind of going off the question of failure, I think probably, even to this, even to this day, I guess I still want to do it, like it happens. And I have I guess the right attitude about it. You have to. But if I can try my best to prevent that, I think one of the things I've picked up, certainly other people have suggested it, it's the idea of like prototyping. I mean, to be able to isolate maybe the process that you're going to do in some other way when the stakes are lower in a different situation, So if you do that, I feel like, and you can learn a lot of things at a smaller scale, then your confidence grows to be able to apply that same logic on the bigger project when you're going to spend a bunch of money and when you're going to invest and have something to deliver. So I usually I try to break down a project the best I can in terms of series of operations or things that we're going to do to be able to pull it off, and then so before I engage in those, try to do simplified again prototypes of each of those operations. So all those kind of help assist in future projects as well, and kind of a library or kind of a database of things that you feel like you have a grasp on, and any opportunity, I guess, to add to that database or add to that set of projects, something that I'm gonna try to do, and then pull from that again in future design. Is that what you're getting at, Brad?
Yeah.
So,
well, and Natalie or Rod, do you have any thoughts on prototyping?
Well, I think the reality of it is that Colby's a better academic than I am. I mean, he researches and looks into things and records and keeps records and all kinds of things. And I'm my dad was a farmer, and he worked in a machine shop. He was the manager of a machine shop, and he had no real education in any area other than high school. And when I was a little kid, he was designing machines that built and created aircraft brakes. And he, how he ever learned to do that, I will never know. But he would buy houses and remodel them and tear the floors out and so forth. And it wasn't any. He just did it, and he learned from that. And Colby has a better strategic approach than that. I mean, I learned from my dad. I just try something. If it doesn't work, I fix it and go on, and don't worry about it. And it's a little bit parallel to design studio. If you're not willing to take some chances in design studio, you're never going to be anything but a crappy architect, because you've got to experiment, you've got to make some mistakes, you've got to screw up, and you've got to learn from it and go on. And I think the same thing is true of building things and materials. Now, you do have the responsibility of not hurting people, and I guess that's a problem. But I just, I really respect Colby's approach, and would recommend it.
But you're firmly committed to your own approach as well, right?
Oh yeah. I would go crazy if I did it Colby's way, but it's the right way. I mean, there's nothing wrong with it at all. I fall down, go boom, and don't worry about it. But Colby wouldn't fall down. He's the guy that would help me up when I fell down.
I'm listening to you, Rod, but I mean, I have to admit, I think I get to watch you every day in the lab over here, and every, there's so many different approaches to achieving the same end. I mean, we're all just slightly different. I don't know about if one's better than the other, but I definitely can see the work being done and on the projects that everyone is engaged with. And again, I think ultimately it comes down to confidence. And obviously, Rod, you have a lot of that. Some of us need to work harder to get to it. So it's all a good thing. Good conversation.
Well, and this is a good segue. So Rod, can you tell us about your current project?
Oh, well, we're building for JP Hall. We're building 3 big round things, big tubes that will be put in the park out by his house. And right now the students they're cutting steel and welding and drilling, and we're going to put we're going to try to put one of them together yet this fall with 2x6s. One of them is going to be at least 16 feet long and about 15 feet in diameter, and the other 2 are smaller in diameter and a little bit shorter. But we had to get steel bent and then cut it every inch so we could curve it and make it into these big circular units. And I had never done that before, but I figured out how based on the width of a saw blade, how often the cuts had to be to make it curve into the radius that we needed on the big one. And then I found out the small one was going to have an infinitely more cuts. So we just did it the way we did the big one, and then bent every other one of them up and down so that they would fold over the top of each other a little bit. And, that was a problem. And the solution was to just bend it a little bit. Yeah, that's it. No, it's the kids are just, they're learning how to run a screwdriver and drill a hole through metal with a hand drill and not break the drill. And if you haven't done that, that's hard to do, because when you get near the end and it goes through and it catches and it twists the drill bit or drill, and it twists the bit and breaks it. And so I've taught them how to resharpen bits after we break them, and shown them how when you get to the end and it just begins to feel a little bit of vibration where it's cut through, you take all the pressure off and just ease it very, very slowly into it. But that's just, it's just experience. You just learn by doing it. And I screw up just like they screw up. I've broken some drill bits. I did it especially for them. No, I didn't.
Well, and we did a material talk on this on the loop. So many of the students, I think all but one, had never welded before.
Yeah.
And then they made the loop. And then can you tell folks about, you had a steel fabricator come? Do you remember that story? So they came and assessed the work, and they said
Oh,
that
yeah.
even
They would have had trouble doing it. Yeah, and that it's interesting because, and don't take this wrong, Natalie, my two best welders were ladies, and the guys knew it, and they really admired them. And the project, they were so engaged with it that I had I think 6 of them graduated, and they stayed more than a week after graduation. They all had jobs, and they stayed a week after graduation and finished it. And that's the kind of thing you admire. That's what you look for in students, that kind of dedication and engagement. And we've got the best ones on campus in this building, I think.
So to everyone really, have you seen the field of making, or in your eyes, how do you see the field of making evolving, if it has, through your time in making?
Quite honestly, I think it may have devolved because I think people want to feel like they're too good for that. And not everybody, but there are some people that do. And I think that's a shame, because I think you come to appreciate the people that you're asking to build the things that you're designing. And doing that will make you a better designer and a better human being, as far as that's concerned. But no, I think we need to promote that as much as we can.
And then Doug, you've worked with designers and project managers. Do you see differences in approaches and how they can complement or contrast one another?
As a CM, it's always extremely important to appreciate the people actually doing the important things, and their skill and knowledge helps solve a lot of problems. I do think that, and maybe unfortunately, that there's going to be an awful lot of more, it's happening, automation, robotics, things like that, which is going to take away some of those skills from some of those people because they're not doing them anymore. But I don't think it's going to work out quite as well. So there's definitely a lot of that going on. I tell my students they'll probably be supervising more robots than they will people.
And then, go ahead.
We don't want to get started on AI, because
No, we don't.
I've had people tell me, how AI is going to become great teachers. And as soon as AI can read a student's mind and look into their face and determine what they're thinking and what they're feeling and touch their heart, it ain't going to happen.
Well, what if we back up and look at things like CNC or other digital fabrication tools?
Well, I can speak to one observation that's changed just even since I was a student, at Ball State, is the accessibility of a lot of those types of machines, stuff that might have otherwise been proprietary knowledge or in industry and harder to for the average person to engage with or program or utilize. So that's a whole other subject, is just being able to kind of be bilingual, I guess, in manual making and sort of digital workflows. But one thing that I know for sure that's part of that, and is the ability to simulate many of the things that you're building, right? And that comes for better, that comes with its own set of dangers. I mentioned earlier, just like things you can't really grasp as a designer of a three-dimensional object in computer space without putting your hands on it and bringing it into the real world, so to speak. So that back and forth, that I think that's obviously something that's evolving when it comes to the research and making, like the fact that I can simulate different types of cuts on a certain type of material and kind of be able to visualize that and get some feedback on that before actually doing the cut itself. I think has taught me a lot. Just it's a simulated feedback. It's not a replacement or better than the actual physical one, but I've been able to kind of maybe catch some things that I would have missed if I just jumped right in. So I think there's a value in that, so long as it's kind of held in the right posture, in regards to the other things that we've already mentioned, the importance of again, just being able to dialogue with builders or specialists in that field, to be able to communicate design intent to them. I don't know. In that regard, I feel like it can help assist catch some of the issues and challenges just through that modeling process that you might not otherwise be able to do without the the current technological sphere that we're in. So, but again, he can hear me saying it. There's obviously, I agree that you can't be over reliant on those sort of tools, and you can't be over trustworthy of the things that you're seeing. But I think if you have the right mindset in regards to both of those things, it can be fruitful.
Well, and I don't know, Natalie, do you have anything? Because the Calibrate project was at a different scale. It might have been the same material that you've worked with before. And how did that involve? And then it even had a second life. I don't know if you want to speak to that.
Oh, it's got multiple. Well, I was just gonna say, I guess kind of going back to the, technology changing. I see every technology and tool that we get is just something, another slot in the toolbox, something to break or something to, figure out how it works and how you make it work for the reason maybe that it wasn't intended for. And I think Calibrate was kind of doing that on multiple levels in terms of, the materials that it was using and the machine parts that it were using. And, it's able to hack into the sensors and the coding that was used by the original FarmBot piece that was on it, through kind of use of the new technologies that enabled me not to be an expert at coding or scripting, but be able to find enough information to do what I need it to do, and just make a mess of things. The project itself has had multiple lives. It, began as sort of this, I don't know, exploration of, what are you interested in and how does it fit into this theme, and changed multiple times in there, but then became that exhibit at Exhibit Columbus, and then moved to the downstairs and had to make modifications in order for it to be inside and do other things. And then it's, it's been recycled into student models and greenhouse pieces and weird lights and a sign in Kentucky for a bridge, and I don't know, sort of all kinds of other things. So I don't know, it's just evolving, always evolving, never finished, right? Sort of the process of making.
Well, and kind of on the other end, I was lucky enough to go on a series of tours with Colby. Can you talk about what you found useful in taking the students to places like the IMI, or the AZZ galvanizing. So this is a place where the raw materials, either the manufacturing, there's additional processes going on with the materials, or the raw materials are extracted.
Yeah, I think it's in this, kind of in the spirit of what we've discussed before. I mean, there's only so much you can gather by sitting in a large presentation hall and looking at PowerPoint slides, for hours on end about different materials. I mean, it's one of the values of the materials library itself, that you can go in there and touch things and look at it and feel the texture and get a sense of how light responds, or all this sort of stuff to the material. So why not take that a step further and go right to the source of where they're either pulled from the earth or fabricated from different types of renewable resources we have. So I know for me as a student, that was very meaningful to be able to just kind of ground the kind of intellectual knowledge about a thing into its actual physicality, and just kind of see it. And I don't know, light bulbs go off in different ways. Even if you're not taking that material and cutting it yet, or even if you're not starting to manipulate it in some form, there's just a deeper appreciation, and again a deeper appreciation for the industries that surround things we take for granted, is just showing up at Lowe's and grabbing some materials off the shelf, and be able to see that what happens behind those shelves, behind the scenes, and how something comes to the market. I think, again, it just enriches the understanding of the whole life cycle of the materials. And I think, again, it kind of has to do with that I don't know, that maybe the deeper appreciation for what you're doing and what you're working with. So if that can be fostered, or if that can be facilitated in some way, then I think a field trip is a good way to do it.
Well, and if I can speak to this, so we went to this AZZ galvanizing, and so they have this huge vat, which they call the kettle, right? And I can't remember, so it has molten zinc in it, and I'm not remembering exactly. It's like somewhere around 1500 degrees Fahrenheit. And so the workers who are surrounding this and dropping basically almost all galvanized steel that we see on the interstate, we take all that stuff for granted. Almost all of it has gone through this one facility. And so we're seeing them work. They're talking to the students afterwards, and they're incredibly gracious hosts. And so it's something that you just really don't think about. And then, yeah, I gained a much deeper appreciation for some of these things that we see every day that we, again, take for granted. Does anyone have any questions for other panelists?
Well,
I guess I do have a question for Doug, in the sense that it's been a while since I've been over there to the AT lab where you do that research, but I know you kind of touched on it, but can you remind me what the actual what type of loading you're testing on some of those machines?
For the two projects, the concrete beam project and the truss project, it's a strength to weight ratio. So we, after they have designed and built their forms and poured their concrete and everything, then we weigh the beams and then put them on the electromechanical testing machine, apply a load to the center of the beam until it fails. And then the strength to weight ratio is what we compare. Group of the best gets the bonus points on the thing. And the wood truss project is the same thing.
I'm sorry, because I know a lot of your projects, but Colby, can you talk about the Bob Ross project?
Yeah, I mean, I think that was a good case study of some of the things I've said before, in the sense that I kind of, the Bob Ross project that Brad's referring to is a giant Bob Ross head and body.
We'll
Kind of in
we'll
the spirit
post a
of,
photo.
yes, kind of in the spirit of an oversized bobblehead was the kind of concept behind it. But it was one of those things where I felt like I had enough knowledge about the machine I was using and the material to commit to doing it, but I didn't quite have all the pieces in between the commitment figured out yet. And so, like as I was saying before, like one of the first things I did was reach out to a few folks here in the college that had worked with foam and finishing foam. There's John Sadler over in the scene shop at the theater department. James Cresties in our college, Michael Lorsung in the School of Art, and yeah, just visited with them, trying to understand all the different types of ways to finish.
I posted the photo. Everyone look at this photo real quick.
Yeah.
It's hard to believe. Sorry, go ahead.
Yeah, just kind of listen to them, going back to that whole map making exercise, I guess, just kind of got a sense of all the products that they recommended and the directions they pointed me in. I synthesized those thoughts into like a 2-page paper or something that I sent back to them just to kind of get I heard a feedback that I heard them right, and then I just started wading into it. And interestingly enough, the product that I ended up using wasn't one of the ones that were recommended. But I wouldn't even had I don't even feel like I would have had a good orientation to go and know what I was looking for and what products to start buying and testing. And I did, cut a few pieces that were used primarily as test pieces, and just so happened the product I needed was a little thicker than normal, so to fill in for a lot of imperfections that were in the cutting process itself. So, and even once we got that stage done of the pieces cut and the finishing done on the outside, another classic example of me not knowing was how to paint, how to paint the ultimately the finishing touches on it. So figuring out what the best approach with that, helping identify people that could fill in those gaps and do some of the finishing touches for me, just kind of underscores like the need for collaboration and throughout that whole process. I mean, I might have been someone that was carrying the point through the process, but all the people that were around me and supported me in that, and obviously were just as critical to its final form and final product. So I don't know if that touches on what you're hoping there, Brad, but it kind of indicates the right, I guess, mindset. I think with being a maker and it's come through all the panelists here is you gotta just kind of dive into something and not be too worried about setbacks and failures, and just have fun with it, make it fun somehow along the way. And that was a project that kind of embodied that.
And then for everyone, is there a project on the horizon, either as part of a class or personally?
I'm going to build another pond.
So you still have that backhoe?
I do. No, I think the key here of all the things you've heard is look at me. You're going to be my age someday. Don't let your life slip by. Take advantage of every opportunity you have to do everything you can possibly do, and experiment, try things, learn from it. Just have a great life. I remember I think there's students listening to this perhaps. I remember being your age, and it wasn't that long ago. It's only like 60 years or so, but just life is so rich and so full of wonderful things to learn and experience that you just don't want to pass them up. And I just got a new puppy, and I'll tell you, you can read about something all you want, but until you experience it, when you hold the puppy in your hand and you smell it and you feel its emotions. You feel its emotions. And, you know, that's different than reading about it. You know, it's just, I'm sorry, I'm weird.
No, I mean, unless anybody else has anything to add.
I was just gonna say there's always something on the horizon. What it is just depends on time, what happens tomorrow, today, whatever. But there's always something. We're always trying to make something. I would guess that's what everybody else is doing.
I think that's a good place to stop then. So feel free, if you have any questions, you can reach out to any of the panelists. And I just really want to thank all of you for participating today. Everybody
Thank
have
you.
a
Thank
everybody
you,
have a
Brad.
great day. Yeah. Thanks so much.